Well, hello and welcome to the Bumper to Bumper podcast. I am Dave Riccio here along with John Riggle, and together we are helping you with your car. We're putting you in the know, car terminology, car understanding. You don't have to know everything about it. Just roughly what's happening with my car and what is
Yeah.
the auto shop telling me.
Yeah.
Put them in the know when it comes to that. Am I fixing the right thing? Am I working with the right shop? That kind of stuff. So this is a huge, and I think most auto mechanics don't necessarily care for, the oversimplification of the scan tool. What the heck is a scan tool? And there's this perception, and I drive with just about every customer that has something where there's a noise or a vibration or a shift concern or a sensation where I can go with the customer and drive it, and they go, well, you guys are just going to plug into it and it's going to tell you what's wrong with it, right?
Yeah.
And that is not the case.
You got that machine that plugs in and tells you what's wrong with the car? That one? Yeah.
That one would be, that one would be really expensive if it existed.
Yeah.
So
that machine winds up being me.
You are that machine. You are the machine, and that is one of the tools in your box is the scan tool. But when you go to the auto parts store, and I'm not against people going to the auto parts store, have them plug into it, get some information. That
doesn't bother me.
It's information, not a problem with that. But to understand what is really happening. So that is just getting a code out of a scan tool is just a little bit of what a scan tool can do.
That's not the that's not really the purpose of scan tools.
Right.
Yeah, that's part of it, but one of the things smart guys figured out back when they started adding computers to cars, when we started doing fuel injection, when we started doing back even in the day of computer controlled carburetors, engineers realized that now all of a sudden we have electronic systems built on top of mechanical systems, and normally when we are looking just mechanical systems, there's little things that we can do to change and make tests and things. And we can just make observations a lot of times and figure out what's going on. But when you add computer controls on top, it adds another layer of sophistication to the system. And we need to be able to make the distinction, is this a basic fundamental mechanical problem, or do we have an issue with the computer control system? Is the computer control system telling the truth? Are the sensors reading correctly? Is it making these changes because it's confused, or is it making changes because there's a mechanical issue and on the actual data it's using is causing it to make some kind of change, right or wrong, to compensate for what's going on? So the scan tool was our window into what the computer was doing.
That was the invention needed to work with a computer control and a mechanical system. How do we know what that computer is doing?
Back in the early days, really early back when we were doing the original mechanical injection systems and stuff, and the start of the electronic ones, we had these big Bosch boxes that you plugged in. And you would go through and you would simulate each one of the signals and stuff. And it was all switches and
I'm so glad I didn't really live in that era. Oh my gosh.
That stuff was kind of crazy. We had lots of workarounds for that stuff. But then they gave us serial data. And the serial data is what really opened the whole thing up. And the serial data means that we can actually see all these different parameters that the car is using to make calculations and adjustments. We can see what the sensor data, what the computer is seeing as far as sensor data and stuff. And that live data is really, really where the power in the scan tool is. It's not just the codes. The codes just give us an indication what it was the PCM or the control module saw that it didn't like, there was some value here that didn't match what the programming was supposed to be.
Yeah. So the codes come in, and essentially what the code is, because you're talking about all these variations, and then somewhere, in the 80s we had electronically controlled carburetors, right?
Yeah.
Early fuel injection, maybe Volkswagen way back in the day was a mechanical fuel injection system. That was kind of the early stuff.
Yeah.
Right. So now we've got to know, and what a code is when it's seeing one of those values get out of whack. The value gets out of whack, it's going to trip a code or set a code, and that's a pointer. But people say, "Oh, you just plug in and it tells you what's wrong." No, because sometimes you plug in and there's nothing in there. you know?
Yeah.
And so there's no codes, and we call that, no code diagnosis is kind of what separates some of the men from the boys, I guess.
Well, yeah,
But
it's funny. I taught for too many years, taught automotive technology, and there was a couple of things that struck me right off the bat. Was most of the guys were using the scan tool just to pull codes out. They were pulling codes out, reading the description. That's the part they were going to put in the car,
right,
or as close to it as they could get. What separated the men from the boys there was the guys that realized that there was all this data on the other side of the scan tool that wasn't just a code. There's all this other data that you can look at and analyze. And the number one question that I used to get asked in classes, which scan tool should I buy?
right.
My answer always was all of them, because they all have gaps, holes, and errors.
Yes, they
in them.
do.
Even the factory tools do. So the other thing we would run into, I would have guys in class, and they'd say, "I've got this car. It's got a solid misfire in it, and there's no codes. How do I fix that?" And I'm looking at them going, "How did you fix them?"
Before we had that,
Before you had computers, same way, man. Do cylinder balance tests or whatever, coil
Right.
output tests. There's all these other tests that we used to do, but the younger guys came into it, and they weren't as experienced doing things like that. I mean, to this day, I still use a vacuum gauge all the time, and I see people that are like, "What do you got a vacuum gauge for?" Well, because you didn't see it,
right.
So then we wind up in the situation, like you said, no code diagnostics. And that's where the guys get in real trouble. I don't have a code. I don't know what to do.
Well, I see this one a lot with, we talk about misfires. I don't see it as much anymore, but I would get cars that referred to the transmission shop from the auto shop because they said the torque converter was chattering. And so they bring it over, and when I'm talking to the customer on the phone, and I say, "Okay, so what happens?" Okay, 45 miles an hour, and they describe the word stutter, or like the transmission doesn't know what gear it's supposed to be in. Those are keywords that flag me. I'm like, "Oh, it's got a misfire, right?"
Right.
But their auto shop referred them over because they think it's a torque converter problem. So it comes over, and I go drive it, and it's got a lean misfire, right at 45 miles an hour, and they think the transmission is trying to upshift and downshift. No, it's the motor's falling on its face, falling on its face, falling on its face. And so that's a misfire, but again, there's no codes in it. So in a Ford, they got mode 6, right? So you can kind of go see what the misfire data looks like. There's parameters before it's going to set a misfire code. So it's going to wait till it sees so many counts before it says, "Hey, we got a problem." But if you never get to that point, again, no code, they think it's a transmission problem, and it's not a transmission problem, but the data is there. So there's live data, and then I see you because sometimes we're driving cars, you're reading the scanner, I'm driving the car, and I'm trying to get in a certain situation in order for it to screw up the data. A lot of times there's not two of us, so you graph stuff. So what does that look like?
Yeah. Oh, okay, so the graphing is where the real power is, because if you think about it, with the digital information, you're only looking at an instant in time. And these systems are dynamic. They're continuously moving and adjusting. All the inputs are changing. So what we try to do is graph the data over a period of time. And a lot of times, if I graph the data, I can overlay the data. I can put cursors in and marks. So if an event happens, if I feel a chuggle or a misfire or something like that, I can strike a line in my data, and I could go down and look at all the different things that changed at the same time. And a lot of times I'm looking for things that didn't change.
Right.
That I expected to change but didn't. So the graphing in the scan tool, again, is another thing that unless you use it on a daily basis, the guys get a little lost in it. It's a little hard for them it's a lot to try to cover because you always have to think about all the exceptions and stuff. And it's like, so with the misfires, one of the misconceptions about misfire is in the OBD2 regulations, they had to have misfire monitors. Well, what people didn't realize was the misfire monitors were phased in at the beginning of OBD2, which started technically with new engine families in 94.
Oh.
Yeah, it wasn't across everybody until 96, but in 94, any new engine families that came out had to be OBD2 certified. So we have this kind of phony OBD1, OBD2 kind of crossover there for a couple of years. But once we got to 96, misfire monitors were part of the, they were integral to the OBD2 system. And one of the things that people don't realize, in 2000, we only did misfire monitoring at certain RPM ranges. We couldn't do full range misfire monitoring because we didn't have the technology there yet. So we used to get these cars in all the time. It's got a misfire in it. You can feel the misfire, but it happens at 4,000 RPM under 80% load or something like that. You could feel it start to secondary misfire, and they'll miss hard, and it's like unmistakable. It's a misfire. We know that, but people got confused. There's no code. Well, the reason there's no code, because they didn't do full range misfire monitoring till after 2001. So there's a long where it was absolutely mandated, where they had to expand that so they could do it. There's other issues. There's times when, and they call the misfire monitor, that is a continuous monitor, which means it runs all the time.
Yeah.
It doesn't necessarily run all the time. That's kind of a misnomer. So when you're on a D cell, you got all the fuel shut off. There's no reason to run a misfire monitor.
Right.
If you're running out of fuel in the car, no sense in running a misfire monitor. So if you got a car that rolls in with a misfire, the fuel level is down below 15%. Odds are the misfire monitor's turned off on some of the older cars. We got better at detecting that stuff and dealing with it.
Well, computers have gotten a lot faster, and they could do a lot more, you know, in the progression of them, to where they're super fast and they can fine tune and make all kinds of adjustments. Yeah. So I wanted to make sure to cover scan tools, code, what is it? Live data, what is that? And then no code diagnosis. So to go back over them, so we're not missing anything. So codes are when the computer sees a number that's out of whack. For long enough. It can't just see it. Sometimes it'll have to see it multiple times before it actually sets a code.
We don't want to set false codes.
Right. And we've even seen manufacturers where their check engine light's coming on too easy, and they go back and they go, oh, we reprogram it to get rid of annoyance check engine lights where there is nothing really wrong. It's just the parameters too tight for what's going on. And they may see it in parts of the country here or there. You know, things change. So a code is a message, and there's standard codes, there's manufacturer-specific codes, but the engineer has predetermined this code number, and therefore these are the circumstances for this code to set. So codes are a piece of the diagnostic, but certainly not all of it. It's a 1 and 5 step process to oversimplify it. You know. So then live data, you ever watch the movie The Matrix? You know, they would stare at the screen and all the numbers would come down, and they were looking at the data. So that's the live data, and there's a lot of data all at once that's going on. But you're going to actually get in the scanner, and you're going to bring up the PIDs, you call them.
Parameter IDs.
Parameter IDs, and you're going to say, okay, in this case, I want to look at engine RPM, transmission input RPM, you know, so you can look at torque converter slip. And I'm also going to look at misfire data in that same thing. And then I may graph that, because a torque converter slip and a misfire, they're like real close. But you get an idea for frequency, and you can spot the difference in the graph, whereas if you hadn't learned that, you say, like with data, people get into trouble because they're not using it on a daily basis. You're using it every day.
Using that example, there's another trick that we look at. When the issue occurs, you feel the car jerking like this, what's the RPM doing? If the torque converter is slipping, over-applying or under-applying, if it's slipping, the RPM goes up. If you have a misfire, RPM goes down.
Right.
So, and you can pick that out in the scan data pretty easy if you know what to look for.
Right, and that's also experience. You've done this once or twice. So live data, that's what it is. That's the thing you're not going to get at the auto parts store. They're gonna, if there's codes in it, they're going to find them for you. They're probably going to recommend whatever is in that code. But so that's what that is. And then no code diagnosis, and this is a common one because I'm driving with people, and they say there's no check engine light. And probably because of the type of business we are, probably better than 60 to 70% of them have no check engine light, have no codes. Because of the type of business. I would say in a transmission shop, that's probably more common.
Yeah.
And transmissions have gotten smarter. I mean, originally they had one speed sensor, then they had two, and some of these things have three.
Oh, yeah.
There's a lot more information than we used to have, so they do set codes more commonly. They can dial it down. And we're dealing with a lot of 8 and 10 speed transmissions anymore.
Yeah.
In the old days, it was like 1, 2, 3, 4
Yeah.
gears. Pretty easy to keep track of them. But with a 10 speed, I'm thinking of the Fords because we see a lot of those lately. But it's sometimes it'll shift from first to third, sometimes from first to second. It just does all kinds of different things. So to be able to track it, see it in the live data, all those things come into play. But diagnostic trouble codes, scan tool, what is it? And you can buy one of these things on eBay, or not eBay, but something that you can plug into, and it'll tell you what codes are in there. And they're a little bit limited because in a car, basically they're going to go and scan the engine control module or the powertrain control module. And they're going to give some basics. But in a car, there's several modules. There's an ABS module. There's sometimes a transmission control module is separate from the engine control module.
I think that Lincoln I worked on the other day had 70 modules in it.
70 modules.
That was like, ugh.
You blew my mind on that Lincoln, by the way. I have no idea how you found a bad factory connection underneath the driver's seat that would change when you move the driver's seat. So anyway, that's So they got modules, and those are all talking, but you're not necessarily going to see the information with a basic scanner. A lot of times we got to go in and dial the address of that scanner.
Yeah, and that's kind of the trick. The scanner that I use on a daily basis, probably 15, 20 grand by the time all was said and done. So
plus the maintenance.
Yeah, $1,200 a year to keep the software updated on it. So that's why I say ideally you'd have them all. Ideally, you could blow $100,000 a year.
Oh yeah,
buying scan tools and software updates. I mean, it's a huge. I mean, maybe not $100,000, but it's a huge number.
It's kind of the way it is in the shop because one technician's got this scanner and that scanner. The next technician's got a different brand, and sometimes we're passing around.
Yeah.
And you'll be working with one brand of scanner, and you're like, I'm not seeing what I want to see. You grab the next guy's scanner, you plug in, and you're like, oh, there it is.
Yeah.
But they're not all perfect, including the factory tool, because we've seen factory tools fall short where an aftermarket tool works better.
There's another aspect to the scan tools, and back to that machine you plug in that tells you what's wrong with the car. The holy grail for automotive manufacturers or dealerships would be to have an automated system that walked through all the tests and told you what to do. And some of the manufacturers use it. It's called guided fault finding.
Right.
Some techs love it. Some techs hate it. Right. But what it does, you plug the scan tool in, and it tells you what to do next.
Check this.
Okay, check this. Check this. Do this. When you have the result, put the answer right here. We'll take you to the next step, and they develop what they call measures plans, which is a diagnostic plan. And a lot of it's real big with the European manufacturers. They really like to do that, and there's reasons to do it. It controls. Make sure that all the techs are doing all the same things every time to get you to the answer, right? So now we have some consistency. We know that they're not skipping steps because that's a big deal.
Oh, yeah.
And that's what the guys hate, because there's a lot of times I can look at something and go, well, I know that's not it because of this, this, and this, but I still have to take the steps to check it. But I already know that's not it. I could skip that, but the tool won't let you.
And we know the whole car, but I'm going to go on transmissions for how many vehicles do we get from regular auto shops? In a vehicle, you dial up the vehicle, and you're in the software in the computer to look at stuff, and it's got code set criteria, and then it's got a set of tests to do.
Yeah.
And number one on every single one of those tests is check the transmission fluid level.
Oh, yeah.
That is number one.
Yeah.
We are in a fast-paced world, and people want answers right now because they got to get their kids to school and they got to get groceries today.
Yeah.
So that pressure and to check the fluid on a transmission is a pain in the butt.
Some of them are.
Yeah. I mean, it's not just a matter of pulling a dipstick out. You got to have the right temperature on the car and this, that, and the other. And so it takes time, but we fixed one just last week that the other shop was like scratching their head. They're like, oh my gosh, what's wrong with this thing? It acts up after 10 miles, this, that, and the other. And I mean, you pulled it in, it was 3 quarts low on fluid.
Yeah. Yeah.
And so we thought that was the answer right off the bat. We knew that probably was, but it came from a certified qualified technician, right?
Yeah.
But he skipped that step in the code set criteria for that. Number one was check the fluid level. He never did. He assumed it was right?
Yeah.
So that's where taking the necessary steps is. But we don't necessarily just go pump 3 quarts into it because we won't. I mean, we could assume that may have fixed it, but we want to verify the symptom and see if we get the code to set that kind of thing.
Yeah.
If we're not going to damage something in the process.
Right.
But then add the fluid. So that's where I do like the step-by-step for some slight level of people that skipping steps is not what you want to do in diagnosis.
Back in the day, we had these big $30,000 engine analyzers.
Oh,
You've
the
seen
Sun
them,
machine,
the
yeah.
big Sun machines and the big Allen machines and stuff. And the guys hated them. Guys just hated them because you had to hook all these probes up. You got oil temperature probes and everything. And then you walk through this routine, and it used to drive the guys nuts because they wanted to see the oil temperature at a certain temperature before they'd let you go on and continue the testing. Well, that was important.
Right.
And the guys used to skip that. The guys that pulled the oil temperature probe out and set it off to the side, and it would screw up the results of the tests that they were doing. It was like, just follow the process.
Follow the procedure.
And I liked it because it made sure that I didn't miss any of the basic stuff. It was really good at rounding up and grabbing a whole bunch of information in a relatively short period of time, and getting all the basic stuff out of the way, which is what I do every day anyways.
Yeah.
But I do it with a check sheet a little bit differently. But guys used to hate that tool. They used to hate those things. And I'm like, man, I wish I had 3 of them here. I hook one up to each car, get through that part, and then we go, do the diagnosis. So
For sure. Well, thanks for joining us. Hope you learned a little something about scan tools. It's not just about codes. It's about all kinds of data and graphing and having the right scan tool. Thanks for joining us. We'll see you next time on Bumper to Bumper Podcast. Well, hello, I'm Dave Riccio, your host of the Bumper to Bumper Podcast, and I would like to thank you for tuning in. If you want one of your car questions to be answered on our podcast, tap the link in the description for a chance to have your question featured. And while you are there, we would love for you to like and subscribe to see more Bumper to Bumper podcasts in the future.